All right, so now we're going to look at the planets of our solar system. All right, so the planets, which planets can support life as we know it? A couple of things we're looking at are composition, so what the planet is made of, atmosphere, the air around the planet, and temperature, so how hot or how cold the planet is. All right, so now on your paper, you have the three things, atmosphere, temperature, and composition, and you are just going to draw a line and match their definitions to that. So go ahead and feel free to pause the video and take a moment and do that. All right, nice job. We're going to keep going. All right, so now you're going to answer this question on your paper. How many planets in our solar system can support life? So what do you think? Before we do this, how many planets do you think can support life? So on your paper at number 2, if you will, please go ahead and circle A for 1. You think 1 planet can support life. B for 2 planets that can support life. C for 3 planets you think can support life. And D, all planets can support life. All right, take a moment, pause the video, and do that. All right, nice job. Let's keep going. All right, so you have this paper, or you have this picture on your paper kind of showing you the characteristics of inner planets and outer planets. Just some things that inner planets have in common. So a pattern that we see is that they're typically a lot smaller than the outer planets, of course. They have no rings around them. They have very few moons. They're typically made up of a rock or a metal, and they're really close together compared to the outer planets. Then when we talk about our outer planets are very, very large. They have a lot of rings typically, especially Saturn, and some of the other planets have rings, not as visible though. They have many moons, and they're made up of gases, and they're very, very far apart. So the next, or then getting into some more specific ones, the inner planets, there are known as our terrestrial rocky planets. They're made up of rock and metal. So anytime you hear the word terrestrial, rocky, we know we are talking about the inner planets. They have no rings. They spin a lot slower, so that means their daytime takes a little while, or it takes some time. So like, Earth takes 24 hours to rotate on its axis. Mercury, Venus, and Mars, sometimes they take a little time too. And they actually have faster orbits. So Earth takes 365 days to go around the sun. And same with the other planets. They're close to that. And we're going to learn more about that next week. Then we have the outer planets, are also known as our gas giants. These outer planets are made of gases and liquids. There's no firm solid surface for them. So what that means is, like, if we go try to land on Jupiter, we will not physically touch ground on Jupiter until we get to the core of Jupiter. So they're made up of gases. That's why we can't really go visit them or explore them more. They have outer planets. They have rings and many moons. And they spin faster. So like their day is a lot shorter than our day. And they actually take a lot longer to go around. Like Jupiter takes 4,333 Earth days to complete 1 year on Jupiter. So quite some time. They've got a lot more space to cover in space. All right, this next activity, what you're going to do is, here is your word bank for this. So you have no rings, many moons, few moons, made up of gases and liquids, made up of rock and metal, Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, Mercury, small rocky planets, large gas giants. You are going to sort these out. So take a moment, pause the video. Here is your word bank, and you are going to tell me what inner planets have what characteristics and are what planets, outer planets have what characteristics and are what planets. Feel free to pause the video now and either rewind to that photo I just showed you, like this one, and fill that chart out, or you can look at the chart, this photo, on your own paper. So take a moment, pause the video, and you can complete that activity now.